out on Collins. I be.
Hello guys, welcome back to Everything You Need. Have you ever thought how bats are able to find their objects or animals even without the light in the darkness? How are the whales able to find their prey from a long distances? Come with me, I will show you the cause. The principle around this mystery is concept of sonar, that is nothing but sound navigation and ranging, or you can also call it as echolocation. We have a sensor named HCSR04 which works on the same principle, has two circular arrangements over it where one of it is transmitter and other is receiver. And we are having a 4 pins which are nothing but VCC, trigger pin, echo and ground. 40 kHz of ultrasonic radiation or sound waves will be released from this transmitter, and whenever an object was hit by them, it gets reflected and detected by the receiver. The angle of this transmission and reception will be around 30 degrees. Whenever receiver receives this reflected sound wave, it gets captured, and based on the time it took from the transmission to the reception, it calculates the distance of the object which is present at a considerable range. So here are some of the features of this sensor HCSR04. Please pause this video and have a look. So let's create an ultrasonic based program. Here we will create a design of circuit and we rename the file as interfacing an Arduino, an ultrasonic sensor with an Arduino. Here we need mainly an Arduino Uno, a small breadboard and an ultrasonic sensor. You have to choose a 4-pin based ultrasonic sensor. In the basic component it will be a 3-pin, so change the components to all, and then in the section of input you will find a 4-pin ultrasonic sensor. Here the 4 pins will be VCC, trigger, echo and ground. So connect the power to the positive terminal of the breadboard and change its color to red, and connect the ground part of the sensor to the negative terminal of the breadboard and change its color to black. Now let's connect the terminals from the Arduino ground pin and be its color to black, and change and connect the 5 volts port positive terminal and change its color to red. Now we will connect the trigger pin and echo pin to the Arduino. Here I will choose the trigger pin to be connected to the port of 10, which is a PWM pin. We have to choose any of the PWM pin given in the Arduino, because PWM pin will give a steady signal, so that we required a continuous flow of the sound waves coming out of our sensor. So we choose a PWM pin and we will connect an echo pin to 8th pin of our digital output pins. So let's change the echo to blue and change the trigger pin to green. Now we have connected our sensor. Now we will go to the code part. We will go to text based code, and I have already created a code. I will paste it here. See, here we will declare an integer variables which is trigger 10. Trigger pin is connected to 10th pin and echo pin is connected to 8th pin. We will take a long and long type of time variable and an int type of distance variable, so that we can use in our calculation. Void setup. In the case of void setup, we will define the pin modes. How the trigger pin is an output pin and echo is an input pin, because trigger is nothing but we are triggering the ultrasonic waves to be go out of our sensor, so it is an output pin. So, and also echo is nothing but we are hearing the received signal and we are capturing it. So for the Arduino it will be an input signal. And we will begin the serial monitor with a baud rate of 9600 as a communication rate. In the place of a void loop, first we'll make the digital write trigger to be low, because previous actions to be minimized and to take the sensor to be into the low state. So we'll make it by using the digital write command trigger low, and we'll wait for 2 microseconds, and then we'll make the sensor to go into the high state. That is nothing but we are transmitting the 40 kilohertz of ultrasonic waves into the area around the sensor. So to make a delay of 10 seconds, nothing but we'll make sure to send our signal 10 seconds 10 microseconds continuously, and then we'll stop our signal by digital write of trigger to be low. So we are triggering the sensor to be into the low state, and after that we will observe some reflections by hitting the objects. Now we have to record them. So we'll make the echo to be high, that is nothing but pulse high of echo of high. So we'll record these values, and this pulse in is a function which reads a high or low pulse on a pin. It accepts pin and state of the pulse as arguments. That is nothing but our pin is echo and the state is high. So it returns the length of the pulse in microseconds. So we will store this in the int type of time long type of time variable. So this pulse corresponds to the time it took to travel the object plus the time traveled on the way back to the receiver. So we'll, as the time is double, that is nothing but this is the time taken by the pulse to travel from the sensor and back return to the receiver. So the time will be 2 times. So to know only the distance of the object, we have to make it a half. So time should be half, and we know the speed of the ultrasonic sensor in a open air space is 0.0344 centimeter per second. So we know the distance equal to speed into time. So we will know the distance of the object, and we will paste our recordings in a serial monitor with a statement of serial print of distance. What is the distance we have calculated from these outputs, and a centimeters as a unit. So let's start our code. Start simulation, and we will see in the serial monitor. Let's check the back and let's see. Here when we change the values gradually, we can observe a change in the values in the serial monitor in this way. I think you are very much clear about this project. If you have any doubts, please comment them, and don't forget to like, share and subscribe to Everything You Need. Thank you.